Hi, this is Mrs. Bolin with your notes for your Unit 5 review for Algebra 1. First of all, on the warm-up, draw an example of a linear function. Remember that a linear function is any function that is a straight line that is not vertical. Question number 2 says evaluate f of x equals 2x minus 1 for x equals 3. So basically what we're going to do is anywhere there's an x, we're going to write a 3. So we're going to plug it in right there, which tells us I'm evaluating the function at 3, and then I'm actually going to plug it in where the x is in the function. So I'm going to say f of 3 is equal to 2 times 3, take away 1. Note that this does not mean f times 3, it means f of 3. So I don't do anything with the left side. This is a label that says I'm plugging into function f, and the value I'm plugging in is 3. So 2 times 3 is 6, take away 1 would be 5. Question number 3 says determine if the table represents a function. And so if it's a function, we look at the inputs. And as long as the inputs are all different, then yes, it is a function. Okay, if we had the same input that then had 2 different outputs, it would not be a function. All right, question number 4 says determine if the equation is linear. In order for it to be a linear function, it looks something like this: y equals mx plus b, or sometimes it might be written in standard form, ax plus by equals c. Either case, this one does not look like that. Okay, it's okay if it's written in function notation, but we cannot divide by x. That is not a linear function. So this is non-linear. Okay. Question number 1 says find the x and y intercepts of the graph of the linear function, then graph the function. So if I want to find the x-intercept, I could plug 0 in for y. When I do that, 4 times 0 is 0, that part just goes away. So really what we can write is 2x equals 12. If we do the same thing and plug in a 0 for x, 2 times 0 is 0. That part really just goes away, and we get negative 4y equals 12. So I can solve each one of those. X is equal to 6, so 4, 5, 6. And then divide by negative 4, so y equals negative 3. So I can put that on there, and then I can connect the dots. And that is how we graph using the x-intercept and the y-intercept. Because remember, when it crosses the x-axis, that's when the value of y is 0. If it crosses the y-axis, that's the value of x is 0. We didn't go to the left or to the right. We're directly on the y-axis. Okay, question number 2 says find the x and y intercepts of the graph of the linear function, then graph the function. Same problem. So I call it the cover-up method, but mathematically that's not really a valid thing. We're plugging in 0, that's why we can kind of just cover it up, because when we multiply by 0, it just turns into a 0. Adding 0 doesn't do anything to our function, so we just have negative 5x equals 15. And for each of these, you're just going to be dividing. So we get x is equal to negative 3. So I'll plot that point on my x-axis. Then I'll do the same thing for y. So I have, if I put a 0 for the x, I get 3y equals 15. Divide by 3 on both sides. So y is equal to 5. And then if I connect the dots, that's what my line looks like. Okay, question number 3 says find the slope of the line. Remember, just some notes for you guys, that slope is equal to the rise over the run. Okay, the rise is how far we either go up or down, and the run, we're always going to be looking at how far do we go over from left to right, just like we read or write. Okay, and so when we talk about up and down, that is the change in y, and the run would be the change in x. That little triangle is a delta, and that just is the symbol that we use for change. You could also write it as an equation. So if we take the second y value and subtract the first y value, that tells you what the change in y was. And then if we take the second x value and subtract the first x value, that tells you what the change in x. Those are just notes to help you understand what it is when we're talking about slope. So if I look at this, I could see, oh, well, the y value keeps going down by 2 every single time. The x value doesn't change at all. We would say the change is 0. Okay, well, am I allowed to divide by 0? We are not. So that will give us something that's undefined. And so you could think of how much nothing can I fit into the number 2. Well, I can keep putting nothing in all day long, right? It keeps going in an infinite number of times. In this situation, the y is going down, 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 but it's never, ever, ever going over in the x direction. That's a vertical line, not a function, definitely fails the vertical line test. So the slope of that one is what we would call undefined. Question number 4 says, find the slope of the line. That's it right there. That's all I have to do. Super easy, right? Okay, because we know that y equals mx plus b, and m is the slope. The slope is the coefficient that's stuck to x. Okay, it tells us what we're changing by each time. So you could just say slope equals -2/3. All right, question number 5 says graph the linear equation. So if we're going to graph this one, I need to find the slope and the y-intercept, which are right here. So the m is 1/2, the b is 2. So what I tell my students is b is where we begin, and then m is how we move. So I begin at +2, and then this is the way I move. Remember, the top number tells us whether we go up or down, and then the bottom number always tells us over. And if you forget, you could just read it. +1 over 2. Okay, so +1 and then over by 2. And when we're graphing these, we go over left to right, just like we were reading, writing. You could go backwards 2, but then you need to do the opposite. So you'd go down 1, backwards 2, and then you can see that fits on the same pattern, and we'll make a straight line. Okay, question number 6, same thing, graph the linear equation. Well, the slope is 3. The y-intercept is -4, so this is where I begin. And remember, I always begin on the y-axis because the way that we got that intercept was by plugging in 0 for x. So y equals -4. I'm going to put that dot down there. And then my slope is 3. Well, if I want to make that into a fraction, I can just put over 1. So I'm going to go up by 3, 1, 2, 3, over 1, 1, 2, 3, over 1. You can do that a few times to get enough dots so you can kind of make a straight line there. All right, question number 7 says, write an equation in standard form that has an x-intercept of 5 and a y-intercept of 6. So the easiest way to do this is just to multiply the 5 and the 6 and get 30. Then you say, what am I going to stick in front of x so that when I divide, I get 5? Well, if I want x to equal 5, I would say, well, that would be 6x equals 30 would be x equals 5. Then if I want y to equal 6, what do I need to multiply the y by? Well, I need to multiply the y by 5. It seems kind of weird because we're reversing those numbers, but you need to kind of think about the problem backwards. All right, question number 8 says, give an example of an equation that is in slope-intercept form with a slope of -2. So remember, slope-intercept form is this, y equals mx plus b. And I forgot to say standard form looks like this, ax plus by equals c. It's when we have the x and the y on the same side, and there's just 3 different coefficients, a, b, and c. They don't really necessarily mean anything in terms of what the graph looks like, whereas this one, we know that this is our slope and this is our y-intercept. So I'm going to write y equals, the only thing they tell us is that the slope has to be -2. And so b can be anything. You could put like +0, you could put +17, you could put -1,000. As long as it has the -2 stuck to the x, then you're fine. You could even put a 0 right there by just not writing anything. Okay, question number 9 says graph the linear equation. Well, if y is always equal to 4, here's where 4 crosses the y-axis. But if no matter what my x is, if x is 2, y would be 4. If x is 4, y would be 4. If x is -1, y would be 4, right? If y is always equal to -4, it's a horizontal line that passes through the y-axis at 4. All right, question number 10 says graph the linear inequality. Well, I'm going to start by finding the slope and the y-intercept. The slope is equal to 2, and the y-intercept is -1. So this, remember, is the same thing as b. This is where we begin at -1. And then my slope, if I want to make it into a fraction, I could just put over 1. So I'm going to go up by 2, over by 1. And I could do that pattern a few times. I could go down by 2, backwards by 1. If I need a few more dots on my graph there, whoops, pretend like the line goes through the dots evenly. All right. Question number 11 says, determine whether point P is a solution of the linear equality. Oh, what did I do wrong? I graphed the equation. This is an inequality, meaning that it's not just the line. It is equal to, see right there, there's an equal to, so that's how I know how to do a solid line. But y is less than, less would be lower than. Okay, so you can go to -1 and think of what are all the values that are less than -1. Well, they would go down, and so that's the direction that we shade from our line. All right, question number 11, determine whether this point is a solution. Well, this is the equation, the inequality that I'm plugging into. I'm going to plug this for x and that for y. So instead of writing the y, I'm going to write a 1. So I'm going to write 1 is bigger than or equal to -3/2. X is 0, and then +4. Well, anytime I multiply by 0, it just turns to 0. So this whole thing kind of goes away there. So I'm just going to say, is 1 bigger than or equal to a +4? Is that true? 1 is bigger than 4? No, that is not true. That's false. So no, this is not a solution to the linear inequality, because when I plug it in, it is not true. All right, question number 12, last one, write the inequality shown in the graph. Well, I'm going to start with, where do we begin? So y, first of all, from where I began, I shaded up. So y is bigger than. It is a solid line, so we put or equal to. If it were a dotted line, I would not put the or equal to. The solid line means that it includes that line. So y is greater than or equal to. The slope goes down. So it goes, I think it goes there and there. Yeah. So down by 2, over by 1. It's kind of hard to tell on those little tiny boxes, but so it goes down by 2, over by 1. You don't have to put the over 1 when it's just a 1. X, and then it crosses through at -1. So this would be our equation. You could write it just like this. Y is greater than or equal to -2x minus 1. All right, and that's it for our review. That is it for Unit 5.